What is up, everybody? We're continuing learning about sequences in Chapter 6, and in particular, in Section 6.2, we're going to learn about a specific type of sequence called arithmetic sequence. Now, you've already learned that a sequence is just a list of numbers arranged according to a rule, and what we're looking at here is a type of sequence that's arranged according to a specific type of rule, and you'll see it's going to be pretty easy. So, arithmetic sequences. Now, the goal here, there will be two for this section, but we'll do one in the second video, is that you will write a general formula for the nth term of an arithmetic sequence. Now, we've learned how to write recursive formulas, we've learned how to write general formulas. Now we're going to focus on the general formula and do it for what's called an arithmetic sequence. Now, the first order of business for us then is going to be to talk about what an arithmetic sequence is. And I've given you examples of a couple of examples of arithmetic sequences here. And we'll look at what makes them arithmetic sequences, talk about the key properties and so forth. And really the thing that makes an arithmetic sequence, the key thing, is that there's what's called a common difference between the terms. Let's take a look at the first sequence here. If you notice, each term is increasing by 8, right? 15 plus 8 is 23. 23 plus 8 is 31. 31 plus 8 is 39. So there's a common difference of 8 between terms. If you look at the second sequence, you're going down by 0.5 each time. So you subtract 0.5, subtract 0.5, subtract 0.5, and you keep getting the next term in the sequence. Okay, so let's make note of what I've said so far. The key feature of arithmetic sequences is that there is a common difference between the terms, and that common difference, we're always going to refer to that as D. Alright, so then we also need to talk about how you just figure out what the common difference is, and simply you find the common difference for any arithmetic sequence by just subtracting a term minus the term before it. Alright, so you subtract the term from the subsequent term, and that gives you a common difference. Often you can notate that this way. If you subtract the nth term minus the n minus first term, it gives you the common difference. Now that could be the third term minus the second term. Could be the second term minus the first term. Could be the 37,000th term minus the 36,999th term. Alright? As long as you find the difference between consecutive terms, then you're going to find the common difference. And always make sure it's the higher numbered term minus the lower numbered term. Okay. And you can see how we would get 8 for the common difference there and negative 0.5 for the common difference there. So if you are able to find out what the common difference is for the terms in an arithmetic sequence, then it turns out you can write an explicit formula, or what's called the general formula, for that sequence with no problem. And I've got on your screen right now the general formula for an arithmetic sequence, and I'm going to explain why that formula is what it is. But you need to make sure that you have it copied down first. Then you can learn how to use it. Take this sequence here as an example. A sequence in which you can easily tell that the common difference is 5, correct? Because that's what 0 minus negative 5 is, that's what 5 minus 0 is, that's what 10 minus 5 is, and so forth. So I'm making note that the common difference is 5. Alright, so remember, what I'm trying to show you is why the general formula is what it is, and I'll explain what all that mess is here in just a little bit. Each term in an arithmetic sequence can always be, the value of each term can always be thought of as taking the first term and adding the common difference a specific number of times to it. And so I'm going to express each of these terms in regards to the common difference and the first term, negative 5. Now let me label something real quickly. And what I labeled was just the term number that corresponds with the value of each term. I also moved the common difference over here so that I would have room to write the nth term over there. We're going to write an expression for that here in a little bit. Now, I said each term can be written in terms of the first term and a common difference. Alright, well, negative 5 will be the same thing as negative 5 plus that common difference of 5 0 times, correct? You'll see where I'm going with this in a moment. I can write 0 as negative 5 plus the common difference one time. I can write 5 as negative 5 plus the common difference of 5 twice, right? Negative 5 plus 2, or sorry, negative 5 plus 10 is 5, and so forth. The fourth term here would be negative 5, the first term, plus the common difference, well, not 4 times, but 3 times, because negative 5 plus 15 will give you 10. And then the fifth term here is the same thing as negative 5 plus the common difference of 5 being added 4 times. And you can see that negative 5 plus 20 is equal to 15. Now what I want you to notice is a pattern between the term number and how many times you add the common difference to get that term. For the first term, you add the common difference 0 times. For the second term, you add the common difference 1 time. For the third term, you add the common difference twice. Do you notice how the number of times you add the common difference is always 1 less than the term number that you're trying to find? So say I wanted to find the 50th term, I would take the first term and add the common difference 49 times. Hopefully you're following what I'm saying here. And that's what this general formula for an arithmetic sequence is telling you. It says that you take the first term, whatever it is, and you add the common difference 1 fewer times than the term number that you were trying to find the value of. Okay? Notice the relationship here between the use of n and how many times you're adding the common difference. This number is 1 less than the term number every time. So for this specific sequence, if I was wanting to tell what the value of the nth term is, I would take the first term, negative 5, and I would add the common difference 1 less than n times. So I would add it plus n minus 1 times, and then the common difference is 5. Does that make some sense? All right, I'm going to talk a little bit more about this just to drill something that will become common sense to you in your head. All right, and this is what I want to get across to you. Anytime you want to find a term, you always just have to figure out how many times you add the common difference to the first term in order to get that. And if you ever want to find the first term, well, that's just the first term times 0 common differences. You want to find the second term, you take the first term and you add the common difference 1 time. If you want to find the 7th term, you would take the first term and you would add the common difference 6 times. Okay? Now we can also apply this in many various ways, but I think you figured it out. Take whatever term number is, add the common difference 1 fewer times than that to the first term. So let's practice that with a couple sequences that we saw earlier. Here's what I want us to do. I want us to write an expression for the nth term of each of these sequences, and then I want us to use that expression for the nth term in order to find the 11th term. Okay, well, so here we go with the formula for the nth term. Remember what you do is you take the first term, which is 15, and you add the common difference 1 fewer time than the term number that you're trying to find. And if we're trying to find the nth term, that means we're adding the common difference n minus 1 times. And the common difference here is 8. I should label that stuff. And you can leave the answer like that, or if you prefer, you can actually go ahead and simplify this algebraic expression here. And I'll do that really quickly, but then I'm going to erase it. I just want you to see that you can do it. You can make that 15 plus 8n minus 8 if you distribute that common difference, and that becomes 8n plus 7. And really the point I want to make by doing that is, first of all, you can simplify the expression, but second of all, whenever you write the general formula for the nth term of an arithmetic sequence, the formula is always going to be a linear expression. 8n plus 7 is a linear expression. Okay, now I said I was going to erase that, and I'm going to. Because in most instances, just leaving it like this, the general formula is sufficient. Now the other thing we need to do still is we need to find the 11th term, and the 11th term is going to be equal to the first term plus 10 common differences. So we're going to do 15 plus 10 times 8. Now notice when n was 11, but for the 11th term, n is equal to 11, and n minus 1 is equal to 10. All right, and then 15 plus 80 is what we have right there. That tells us that the 11th term would be 95. All right, you should try the next one on your own. Pause, go for it, we'll check. Now remember that the common difference here from when we saw this a few slides back was negative 0.5, and in the first term is 2.5, and so the nth term expression is going to be 2.5 plus n minus 1 times the common difference, which is negative 0.5. Well, that kind of looks like an 8, doesn't it? Negative 0, that still looks like an 8, darn. Hey, I think I got a 5 there. All right, excellent. And then let's find the 11th term if you haven't already. And it would be equal to 2.5 plus 10, again, 11th term, add the common difference 10 times, plus 10 times negative 0.5. And that's 2.5 plus negative 5 basically, which is going to give you negative 2.5. Pretty easy to write the general formula for an arithmetic expression, isn't it? Arithmetic sequence. Now, I want to go ahead and do one more thing within this video. We're going to take a look at what are called finite sequences. Now, a finite sequence has nothing to do with the type of pattern that you see. So you can have an arithmetic sequence that's finite, but you can also have an arithmetic sequence that's infinite. When I refer to finite, I just mean there's a limited number of terms here, whereas if a sequence is infinite, there's an unlimited number of terms, and I'll label that. Sometimes it's useful to just say you can keep adding terms to a sequence. Sometimes there's a reason to only have 20 terms or 30 terms or 2 terms or that kind of thing. Probably not 2 terms, but you get the idea. Now, an example of how you would look at a sequence and know that it's infinite versus finite, I'm going to write the same sequence, but one's infinite and one's finite for you. You'll always know that a sequence is infinite if at the end of the sequence they put this dot, dot, dot to indicate that the sequence continues on further past the last term that you were given. Whereas in a finite sequence, maybe I want this to break off at a certain number. Now I'll show you in a moment how to figure out how many terms there would have been from here to there. But we're stopping this sequence when it gets to 42 is what this says. This ellipse just means we're not writing all the numbers between here and here. But we are stopping right there because you don't see more ellipses at the end. All right, hopefully that concept of infinite versus finite makes sense. Now, in order to answer the next question, you have to have a finite sequence because it wouldn't make sense with an infinite sequence. Another thing I'm expecting you to be able to do is to find the number of terms in a sequence. And the key to being able to figure out how many terms are in this sequence is simply we want to figure out how many times would you add the common difference to the first term in order to get this term right here, right? So let's see how we figure that out. First of all, let's recognize that the common difference is negative 15 because we're decreasing by 15 each time. Or in other words, negative 27 minus negative 12 is negative 15. Negative 42 minus negative 27 is negative 15, and so forth. All right. Now, I said I want to figure out how many times would you add this common difference to the first term in order to get the last term. And here's the way that you do that. It's a little bit of a formula itself, but I'm hoping this is kind of second nature to you. If I want to figure out how many times I add this common difference to get from here to there, then I need to figure out what is the difference between the first term and the last term, and then divide by the common difference to see how many of those there are. All right, so the first term and the last term, I pointed those in opposite directions, are negative 270 apart. And if I want to figure out how many negative 15s go into negative 270, or how many common differences here go into negative 270. I want to divide negative 270 by negative 15. All right, and so it turns out there were 18 common differences added to negative 12 in order to get to negative 282. All right, now let's use a little bit more logic here. If I take the first term and I add the common difference 18 times, which term in the sequence is that going to give me? Well, it's going to give me the 19th term in the sequence. Okay, so negative 282 is the 19th term in the sequence. Now let's try that with another example, last one in this video. Again, if I want to figure out how many terms there are between the first term and the last term, if I want to figure out how many terms there are in the sequence, I need to figure out how many common differences there are between the first term and the last term. So, last term minus the first term. Now the common difference here is 2/4. I know that's 1/2, but I think in this sequence we're pretty safe if we leave it unsimplified. A lot of times with sequences you won't simplify our fractions. Anyway, that's for a little bit later. This will tell us what the complete difference is, and then we're going to divide that by how many by the value of the common difference. That'll tell us how many common differences there are. So we're going to get 70/4 divided by 2/4, which we know we can make 70/4 times 4/2. And then the 4s will cancel, the 70 becomes a 35, the 2 becomes a 1. So we end up finding out 35 times you could add that difference 2/4 to the first term in order to get the last term. And so if we're saying that we would add the common difference 35 times to the first term, well, use of 1 plus 35 common differences is going to get you the 36th term every time. So there are 36 terms in that sequence. Alright, none of it's too complicated, it just took a little while to explain, that's all. Thanks for watching. We'll do more with arithmetic sequences and then geometric sequences in the following videos.